Hey there, hope you're having a wonderful day. In this video, we're going to be coding Space Invaders in Java. This is the game that we'll be coding in this tutorial. And as you can see, we have the Space Invaders and they are moving to the right. And when they touch the boundary on the right, they move down one row. And I have the ship here and I can fire bullets by pressing on the space bar. And as you can see, the score goes up every time I defeat an alien. And if I clear all the aliens for the turn, then we generate new ones. So let's keep on playing. And as you can see, every time we generate more aliens. And the goal of the game is to get as high of a score as you can by destroying all the aliens. And if the aliens keep on advancing and they end up in the same row as a ship, then we get game over. So when game over happens, you can press any key. So if I press, let's say, any letter key or the space bar, the game will restart. Okay? And every time the aliens will be in different colors. So I just added this as a fun thing to do for the game. But yeah, that's basically what we'll have at the end of this tutorial. Alright, so before we begin coding, I just want to quickly mention that I am working on various coding tutorials. So you can find the list of tutorials on my YouTube channel as well as on kennyipcoding.com. So here I have some programming basics in Python and C++, and I have some game tutorials in Python. So currently I have Snake and Tic-Tac-Toe. But in the future, I will add more tutorials in Python. And currently for Java game tutorials, we have Space Invader, which is this tutorial here. And I already have tutorials for the Chrome Dinosaur game, the Flappy Bird game, Whack-A-Mole, Blackjack, Minesweeper, Tic-Tac-Toe, and Snake. And I have a ton of tutorials in JavaScript. So I have tutorial on Doodle Jump, Breakout, Flappy Bird, Space Invaders as well. Chrome Dinosaur game, Wordle, Sudoku, Minesweeper, and Candy Crush, and so on. So again, you can find the list of tutorials on kennyipcoding.com as well as on my YouTube channel. And if you want to stay up to date for more tutorials, make sure you subscribe to the channel. Alright, so for this tutorial, I will be using Visual Studio Code. And if you want to learn how to set up Java with Visual Studio Code, I have a tutorial on how to do so, and I will link the video in the description below. Alright, so let's begin. Press Ctrl-Shift-P at the same time, and then we're going to do Java, create Java project, no build tools, and I'm going to select the desktop as my project location. For the project name, I'm going to call it Space Invaders. Alright, so now we have our project folder. If I click source, we have an app.java folder, and this is where our main function is. And we can get rid of this line here, so I'm going to go ahead and do that. Alright, so the first thing we need for our game is the window. So here I'm going to import javax.swing.asterisk. So we are going to divide our window into tiles. So as you can see, we have 16 rows and 16 columns. And each tile, each square that you see is 32 pixels by 32 pixels. So every square is 32 by 32. So the width is going to be 16 columns times 32, which gives us 512. And the height is going to be the same. We'll have 16 rows times 32, and together we'll get 512 pixels. Okay, so we are going to divide the window into squares. So here I'm going to add a few variables. So int tile size is going to be 32 pixels. And we have int rows. We have 16 rows. And for columns, we have 16 columns. And let's do the math over here. So board width is going to be tile size times the number of columns. So this is 32 times 16, and this gives us 512 pixels. And let's do the same for the height. So int board height is going to be tile size times the number of rows. So this is 32 times 16, which is also 512 pixels. Now I could hard code this and just say board width is equal to 512, but I think this setup is a lot easier because let's say you want to change the number of rows and columns, you can just change one number and then it will affect the other. So this is something that you can do after this tutorial if you want to make the screen size bigger, but for now this is what I'll have. Alright, so now that we have our window variables, let's create our window. So the window is going to be a jframe. So jframe, frame is equal to new jframe, and here we can pass in a title for our window, and I will call it Space Invaders. And then I want to make the frame visible so that we can see the window. So I'll do frame.setVisible to true. Next, let's do frame.setLocation relative to, and I'm going to pass in null. So what this does is it will open up the window at the center of our computer screen. And then I'm going to do frame.setResizable and make it false. So this is going to make it so that the user cannot change the size of the window by dragging on the side of the window. And then afterwards, I'm going to do frame.setDefault close operation, and I'm going to make it jframe.exitOnClose. So basically, when we press the X button on the window, we're going to terminate the program. Alright, so we have our window here. Now if I save and run the program, you can see we have the window, and actually I forgot to set the board width and height. So that's why this window is so small. So let's close this. So over here, I'm going to do frame.setSize, board width, and board height. Okay, so now it's going to be 512 pixels by 512 pixels. Alright, now let's save and run the program. Alright, cool. So we have our window here, and it is 512 pixels by 512 pixels. And I cannot expand it by dragging along the sides. And it opens at the center of our screen, and if I press on the X button, it'll terminate the program. Alright, so now that we have our window, what we need is a jpanel. And the jpanel is something that we add to the frame. So the jpanel lets us render graphics and draw our game. So over here, I would create a jpanel and add it to the frame. But what I'm going to do is I'm going to create another class that will inherit the jpanel. So in our source folder, I'm going to right click, new Java file, and it's going to be a class, and I'm going to call it Space Invaders. So we now have a Space Invaders class, and here I'm going to add some import statements. So I'm going to import java.awt.*, import java.awt.event.*, import java.util.arrayList, import java.util.random, and import javax.swing.*. So these two libraries and the swing library we are going to use for our game, and the ArrayList is going to be used for storing all the aliens and the bullets that we fire. And this random is just for fun. We're going to use this to randomly select a color for the aliens. Alright, so now we have our import statements. Now let's have Space Invaders, this class, extends jpanel. And for those of you who don't know what inheritance is, basically, this jpanel is a class that allows us to draw, and we are going to have this new class, Space Invaders, take on all the properties of this jpanel class. So essentially, Space Invaders is another jpanel, except we can add more data members and functions or methods. So it's basically a jpanel with more things that we can add. So let's define a few variables for our game. So similar to our window, we need to specify the size of our panel that we're going to be drawing on. So we're just going to use the same variables as before. So I'm going to have int tile size equal to 32, int rows is equal to 16, int columns is equal to 16, and then int board width is going to be tile size times columns. So again, this is 32 times 16, and then int board height is going to be tile size times rows. All right, now let's create a constructor. So Space Invaders, and here I'm going to call setPreferredSize. So this is a method that belongs to jpanel, and we are going to do new dimension, and I'm going to pass in board width and board height. So this is going to create a jpanel that will be 512 pixels by 512 pixels, and we're going to add this to the window. So the reason why we use setPreferredSize is because with the window, we have the top bar where the title is, and that 512 pixels accounts for that top bar. So for that reason, we want to make sure that our jpanel is actually 512 pixels by 512 pixels. And let's also set a background color. So I'm going to do set background color dot black. All right, so you can use any color that you want. If you do color dot red, it'll make it red. You can also do color dot white or green. And you can also specify RGB values, so it doesn't have to be a built-in color. But for this game, I'm going to make it black. All right, so we have our Space Invaders jpanel, and back to our app.java file, I'm going to create an instance of the Space Invaders jpanel. So here I'm going to do space invaders is equal to new space invaders. So we have our jpanel here, and I'm going to add it to the window. So frame.add space invaders. And then I'm going to do frame.pack. And then instead of setting visibility over here, I'm going to take this, comment it out, and set it over here. So generally, you want to set visibility after you've added all the components in your window. All right, so now let's save and run the program. And as you can see, we have our window, and inside our window, we have a jpanel, which is the Space Invaders object, and the background is black, and it is 512 pixels by 512 pixels. So now let's draw some images. And in order to draw the images, we need to load the images first. So in the video description, you will find a GitHub link. The GitHub link will have the completed code and the images for this project. So just click on the link and download the project, and you'll find these 5 images. 4 of them are aliens of different colors, and we also have the ship, which is the player. So just take these images and add them to your project folder. So I'm going to drag them to my source folder over here. And then I will do the same for the ship. All right, so now we have these 4 images. And yeah, so just take those images, add them to your source folder, and let's continue on with the tutorial. So let's create some variables to store these images. So I'm going to do image, ship image. And then for the aliens, we have 4 of them. So I'm going to do image, alien image. So this is going to be the white alien. And then we have 3 other colors. So image, alien cyan image, image, alien magenta image, and image, alien yellow image. And then I'm going to create an array list to store the images of the aliens so that we can pick one at random. So I'm going to do array list image, alien image array. And let's collapse this. Okay, so now I want to load the images. So in the constructor, I'm going to do ship image is equal to new image icon get class dot get resource dot slash ship dot png. So this is going to get the image icon. So we want an image object instead. So I'm going to do dot get image. So this line may look confusing. So get class is basically the location where this Space Invaders.java file is, and we want to get resource starting from this location. So the location is basically the source folder. That's where our Java files are. So this dot slash means start looking from this folder, and then we have the name of the file, which is ship.png. Okay. And let's do the same for the aliens. So here I'm just going to copy and paste this. So we have 4 aliens, and the first one I'm going to change to alien image, and the file name is just alien.png. And the second one is going to be alien cyan image, and this will be alien-cyan.png. And then next we have alien magenta image, and the file name is alien-magenta.png. And then finally, we have alien yellow image, and this is alien-yellow.png. Okay, so just to make sure our file names match. All right, so now that we've loaded all the images, let's add them to an array list. So we have alien image array. This is going to be new array list, image, and I'm going to do alien image array dot add alien image, and I'm going to copy and paste this 3 more times. Okay, so here we're going to change this to alien cyan image, and then here is going to be alien magenta image, and then finally we have alien yellow image. Cool, so now we have all the images loaded, and the first thing I want to draw is the ship. So whenever we're drawing, we need to define 4 things: the X and Y position and the width and height of the image. So let's say we want to draw this ship. Well, we need to determine where to draw it on the panel. So we need to figure out what this point is. And then after we figure out the X and Y position, which is always referring to the top left corner of the image. So just like how the top left corner starts at 0, 0 for our window, the top left corner of the image is where the X and Y position would be. So from this point, we specify a width and a height. Okay, so this will allow us to draw the image. So for every image that we draw, whether it's the alien or the ship, we need to specify an X and Y position and a width and height. So I'm going to abstract this by creating a class. So up here, I'm just going to create another class. So class block, and it's going to have these 4 values. So int X, int Y, int width, int height, and then I also want to add a 5th value, which is the image. So image, and I'm going to use the same class to represent the aliens and the bullets as well. So for that reason, I'm going to add 2 more fields here, boolean alive, and I'm going to just make this true, and we are only going to be using this for aliens. And then I'm going to create another field, which is used, and I'm going to initialize this to false, and this is used for the bullets. So this is not the cleanest way to do this. Ideally, maybe you want to create just a block class and use inheritance, but for now, I'm going to put everything in one class, okay? So the ship, aliens, and bullets will all use this same class. So let's create the constructor, and we are going to pass in int X, int Y, int width, int height, and image. So this dot X is equal to X, this dot Y is equal to Y, this dot width is equal to width, this dot height is equal to height, and this dot image is equal to image. All right, now let's scroll down over here, and I'm going to add some variables for the ship. So we need a width, height, X position, and Y position. Let's do ship width. This is going to be tile size times 2. So each tile is a square, so the width is going to be 2 squares, and ship height is going to be tile size. So the height is 1 square, and the width is 2 squares, so it's a rectangle. So the tile size is 32, so the width is 64 pixels, and the height is 32 pixels. So now we need to determine what the X and Y position is. So here I'm going to do a little bit of math. So int ship X is going to be tile size times columns divided by 2 minus tile size. And ship Y is going to be board height, which is basically tile size times the number of rows. So it's going to be board height minus tile size times 2. So these numbers may be confusing to you, so let's go over what these numbers mean. So the height is going to be 32 pixels, so 1 tile size, and the width is 64 pixels, so 2 tile size. So this one should be simple. Now, how can we get to this point? What is the X and Y position? So as you can see, we have 16 columns, and if I take that value and divide it by 2, we get 8. Because we want to put this ship at the center of our screen. If I put it at index 8, then it's going to start over here. So it would be over here. And as you can see, it's not even. We have 6 over here, and then over here we have 8. So on the screen, this would be X equals tile size times columns divided by 2. Okay? So we have 16 columns divided by 2, we get 8. So we are basically moving 8 tiles to the right. So this is not even. For that reason, we want to move back one tile so that it will start over here instead of over here. So we are going to subtract tile size. All right, so now we have the X position, which will be over here. But what about the Y position? So we know how much we need to move to the right, but how much do we need to move downwards? Well, we want to place it over here, which is at row 14. So if we want to place it at row 14, what we did was Y is equal to board height minus tile size times 2. So board height is over here. It's going to start over here. This is where the Y position would be if we start at board height. So from this point, we want to go up 2 tiles. For that reason, we subtract tile size times 2. So for the X position, we will do tile size times columns divided by 2 minus tile size. So we have 16 columns divided by 2, we get 8, and then we jump back to 7. So the X position will be over here. And for the Y position, we would just take the height or the number of rows times tile size. So it'll be 16 times 32, which is 512. So we would start over here, but we want to start over here, right? So we move back up 2 tiles, 1, 2, okay? So that's how we can get the X and Y position of the ship. All right, so let's create a block, ship, and then in our constructor, I'm going to create the block object. So ship is equal to new block. And let's pass in the X and Y position as well as the width, height, and image. So ship X, ship Y, ship width, ship height, and ship image. So the jpanel has a paint component function. So I'm going to define it here, paint component, and it takes in graphics G. And we're going to do super.paint component. So basically, we're going to call the paint component function of jpanel, which we inherit. And then after we do that, we're going to call another function called draw and pass in G. So let's define the draw function here. So public void draw graphics G. And within this function, we're going to be drawing everything. So this will draw the ship, the aliens, the bullets. So here I'm going to do g.drawImage, ship.image, ship.x, ship.y, ship.width, and ship.height. And there's another parameter, and we don't need to pass in this parameter, so I'm just going to pass in null. All right, so now let's save and run the program. And you can see we have our ship down here, okay? Now the thing with paint component is it only gets called once when we initialize our object. So in our game, we want to constantly update the graphics as we move the ship and as we fire the bullets. We want to continue painting so that it reflects the changes. So in order to continue painting, we need something called a game loop. So the game loop is going to be a timer. So let's scroll up, and then here I'm going to create a timer game loop. And in our constructor, let's create the game loop. So new timer. And here we need to define 2 things. The delay, which is how many times we want to call an action. In this case, I'm going to do 1000. So this is in milliseconds. So 1000 milliseconds is 1 second. So if I do 1000 divided by 60, this will be around 16.6 milliseconds. So basically, by dividing 1 second by 60, we are doing 60 frames per second. And then here, I need to specify an action. What do I want to repeat? And in this case, I'm just going to do this. So this refers to the Space Invaders class, and we need to define an action listener. So I could create a new action listener, but I already have a class here, so I'm going to use the interface. So here I'm going to do Space Invaders, implements, action listener. And here you can see we get some red squiggle. That means we need to implement some methods. So if I hover over the class name, which is Space Invaders, and I click on Quick Fix, add unimplemented methods, if I scroll down, you can see we have an action performed. So 60 times a second, we're going to be calling this action performed function. So let's get rid of this. And what are we going to do for action performed? Well, we are just going to draw again. So there is a built-in function called repaint, which we'll call paint component again. So that's all we need. So 60 frames per second, we are going to be calling this action over and over again. And up here, we need to start the timer. So in order to have the game loop begin, we need to do game loop.start. All right, now let's save and run the program. And here you can see we have our game and we have our ship, and this jpanel is painting 60 times per second. So it's redrawing and redrawing over and over again. And you don't see any difference because we do not update the drawing. So the ship is staying in the same position. So let's add some key handlers that will move the ship left and right so that you can see a difference. So in order to move the ship, we need to specify a velocity. And a velocity is basically a change in position over time. So here you can see on the left side, we have 0, and on the right side, we have column 16, or rather, if you want to convert this to pixels, we would do 16 times 32. So this is 512. So over here is 512, and over here is 0. So if I want to move to the left, I need to subtract. And if I want to move to the right, I need to add. When we're moving left and right, we are updating the X position. So currently the X position of our ship is at 7 times tile size, which is 32. So if I want to move one tile over, I will need to subtract 32. And if I want to move one tile to the right, I will need to add 32. Okay, so if I press on the left arrow key, I want to move over one tile. And if I press on the right arrow key, I want to move over one tile to the right. And in this game, we only move left and right. So we are not going to worry about velocity Y. So we do not need to worry about the Y position of this ship. So here I'm going to do int ship velocity X, and I'm going to set it to tile size. I want our Space Invaders class, this jpanel, to listen for key inputs. So I'm going to have it implement key listener. And just like with action listener, we have some unimplemented methods. So if I hover over and I click quick fix, add unimplemented methods, and I scroll down, you can see we have these 3 functions for processing key inputs. So the first one is key typed, which is basically when you're typing on a key, you want to figure out what key the person typed. So if you press on A, this will be the character A. And if you press on 5, this will be the character 5. In this case, we do not need key type. The next one is key pressed. So this is basically whenever you're pressing onto a key. And for this game, it is important that the user presses on the key and then lets go so that the key goes back up. Otherwise, if the user holds on to the left arrow key, they will continue to move to the left. And if the user, let's say, presses the spacebar key and doesn't let go, they can fire bullets quickly without any delay. So for that reason, we want to use key released, which is basically when you press a key and you let go and the key goes back up. So here I'm just going to close this and we're going to use key released. So here we have a key event and let's make a check to see which key the user pressed. So I'm going to do if e.getKeyCode is equal to key event.vk left. This means the left arrow key. I'm going to do ship.x minus equal ship velocity x. So this is going to move left one tile. Else, if e.getKeyCode is equal to key event.vk right, I'm going to do ship.x plus equal ship velocity x. So this is going to move right one tile. All right, so if I press left, it's going to move left. And if I press right, it's going to move right. And actually in our constructor, we need to add 2 more things. One is set focusable true. And basically, we want this Space Invaders jpanel to be the one listening for key presses. And then add key listener. I'm going to do this. So Space Invaders, this class is a key listener. So it's going to listen for key inputs. And depending on what we input, it's going to process the input with the key release function. And one more thing we need to add is within our app.java file, over here, I want to do space invaders dot request focused. All right. So now if I save and run the program and I press the left arrow key, it moves to the left. And if I press the right arrow key, it moves to the right. Okay. And we have one issue, and that is we can actually move past the boundaries So here you can see we move left and now the ship is gone. And I can also do the same by moving right. So let's fix this. So here we're going to make another check. We are only going to move left if we know that moving left is not going to cross the boundaries. So here I'm going to do, if we press the arrow key left and ship.x minus ship velocity x is greater than or equal to 0. So 0 is the left boundary of our game panel. So here we're making a check to see if we were to change the position, would this still be greater than 0? So greater than 0 means to the right of the left boundary. And let's do the same over here. So and ship.x plus ship.width. And the reason why we need to add the width is because the x position refers to the left side. So x and y position refers to the top left. So if I do ship.x plus ship.width, we get the right side of the ship plus ship velocity x. So here we want to make sure that this does not exceed the board width. So board width. So if the right side of the ship, if we add one tile over, if it exceeds the board width, then we are not going to allow the ship to move. So let's save and run the program. So we have our ship. If I press the left key, you can see I can no longer move left because then we'll pass 0. And if I move right, you can see I cannot move right anymore because then we'll pass the board width. Okay? Alright, so we now have a functioning ship over here. The next thing we need to do is add the aliens. So just like with our ship, we need to define an x and y position for the aliens, as well as a width and height. So I'm going to be storing all the aliens in an array. So I'm going to do array list, block, aliens. And then just like with the ship, let's define the width, height, x and y positions. So I'm going to do int alien width. And this is going to be the same thing, tile size times 2. So the width is going to be 2 tiles. And int alien height is going to be tile size. And for the x and y position, I'm just going to make it start 1 tile to the right and 1 tile down. So the first alien is going to start at this point, 1 tile to the right and 1 tile down, okay? And then the width is 2 tiles and the height is 1 tile, okay? So this is the first alien that we'll be drawing. So int alien x is going to be tile size, and int alien y is also going to be tile size. Next, we need to determine how many aliens we want in a row, and how many aliens we want in a column. So to begin, I'm just going to have 2 rows and 3 columns of aliens. So this is what I have here. We have 2 rows and 3 columns. So in total, we have 6 aliens to begin with. So int alien rows is going to be 2, and int alien columns is going to be 3. And then let's keep track of how many aliens we have currently. So alien count, we're going to just set this to 0. Alright, so now we have all the variables for our aliens. And actually, for the array list, I'm going to rename this. So instead of aliens, I will name it alien array, just so that it's consistent with the naming for the other variables. And then within the constructor, I'm going to create the array list. So alien array is equal to new array list, block. And right before we start the timer, I want to create all the aliens. So I'm going to call a function called create aliens. And we need to define this function. So I'm going to do it down here under the draw function. So public void create aliens. I'm going to create a random object. So random is equal to new random. And this is going to be used for randomly selecting an image for the aliens. So we have 4 aliens of different colors. So I'm going to loop through every single row and then every single column, and I'm going to place an alien. So for int r is equal to 0, r is less than alien rows, r++. For int c is equal to 0, c is less than alien columns, c++. I'm going to get a random index for the alien image array. So int random image index is equal to random.nextInt, And this is going to take in the upper bound. So I'm going to pass in alien image array dot size. So this is going to get the next integer, but it does not include the value we pass in. So if the size is 4 for 4 images, then random.nextInt will spit out a number between 0 and 3. So it'll be the indices 0, 1, 2, and 3. All right, now let's create an alien. So block alien is equal to new block. And we need to pass in an x, y, width, and height, and the image. So the x is going to be alien x plus c times alien width. And y position is going to be alien y plus r times alien height. And then we pass in alien width, alien height, and alien image array dot get random image index. And don't forget the semicolon here. So we are doing some math here to determine where to place the alien. So alien x and y are the starting positions. So c times alien width is basically the offset. So the first alien we're going to place over here, and then we need to determine the next alien that we're placing for this specific row. So we would need the x position over here. So to get from here to here, we would need to jump alien width times 1. So we're going to take alien x plus the current column times alien width, which would give us over here. So this would be if columns 1. And if columns 2, we would jump twice. So 1, 2. Okay? And then if we're going to draw another one, we would jump 3 times. So we would place it over here. And then after we finish the row, we go on to the next row. So we jump down 1 and we repeat the process. Okay, so we draw one over here, and then here, and then here. Okay? So for each row, we need to place each alien on a specific x position. So this is the starting x position, and then we use this as the offset. So if we are at the first alien, which is at index 0, we don't do this addition, we just get alien x. And then if we have the next alien, which is at column 1, then we do 1 times alien width. So we take the starting alien x and add 1 alien width, and then 2 alien width, and then 3, and so on, okay? And we do the same for the rows. All right, so now after we create the alien, we're going to add it to the array. So alien array dot add alien. And then at the very end, we need to take the count for how many aliens we need to destroy. So alien count is just going to be alien array dot size. Okay, so we call create alien, and then we need to draw the aliens. So far we're just drawing the ship, so let's draw the aliens here. So since we have an array of aliens, we need to loop through all the aliens. So for int I is equal to 0, I less than alien array dot size, I plus plus. We're going to get the current alien at the index. So block alien is equal to alien array dot get I. And we only want to draw the alien if the alien is alive. So when we're shooting the bullets, if the bullets collide with the aliens, we basically destroy the alien. So we don't want to display any aliens that have been destroyed. So here I'm going to do if alien dot alive. So if you remember, alien.alive, basically it's a boolean, and we default it to true because in the beginning all the aliens are alive. So every time we destroy an alien, we switch the bool to false. So if alien.alive, we're going to do g.drawImage, alien.image, alien.x, alien.y, alien.width, alien.height, and null. All right, now let's save and run the program. And as you can see, we've generated 6 aliens. So we have 2 rows, and in each row we have 3 aliens. And you can see the colors are random. So if I close this and I run the program again, you see we get different colors. Okay? All right, so we have the aliens generated. Now the next thing we need to do is make the aliens move. And the aliens move from left to right. So we need to give them a velocity x. So up here, I'm going to do int alien velocity x, and I'm going to set this to 1. So this means we are moving over 1 pixel every time. And so we need to apply this velocity to each of the aliens. So underneath the draw function, I'm going to create another function called move. And this is going to handle all the movements for the aliens and the bullets. So again, I'm going to iterate through all the aliens in the array. So int I is equal to 0. I is less than alien array dot size I plus plus. Let's get the current alien at the index. So block alien is equal to alien array dot get I. And we only want to move the alien if it is still alive. So if alien dot alive, I'm going to do alien dot x plus equal alien velocity x. And I'm going to call this move function inside our action performed. So right before we repaint, I'm going to update all the x positions of the aliens. So I'm going to call move here. So if the aliens are moving to the right at a pace of 1 pixel, and we're calling action performed 60 times per second, that means every second, each alien would have moved 60 pixels. So if I save and run the program, you can see the aliens are moving towards the right at a rate of 1 pixel. And you can see the aliens are now moving off the screen. So in Space Invaders, when the aliens touch the border, they go down 1 row and they reverse course. So in Space Invaders, whenever the aliens advance towards the right and they hit the end, they advance 1 row. So they go down 1 row towards you and then they switch course. So they reverse direction. And then when they get over here, they go back down again and then they switch direction. Okay, so let's implement this. So in the move function, if the alien touches the borders, we need to reverse course and bump them down 1 row. So first we need to make the check. If alien.x plus alien.width, so alien x is the left side, so by adding the width, we get the right side. If this is greater than or equal to board width, or alien.x is less than or equal to 0, so this part checks the right side touching the right side of the screen, and alien x is the left side, so this is checking to see if it's less than or equal to 0, which is the left side of the screen. So if the alien touches either the right side or the left side, we are going to reverse course. So we're going to do alien velocity x times equal -1. So we're just flipping the sign. So if it's going to the right, it's positive, and if it's going to the left, it's negative. And then here, because we've already gone past the border, we need to step back. So I'm going to do alien.x plus equal alien velocity x times 2. And the reason why I do times 2 is the moment we add 1 and we go off the right border, we need to add 1 back. And when we add 1 back, we are essentially at the right border. So we need to add 1 more so that it is in the right direction to the left. So basically what I mean is if the alien gets over here, we need to make the alien go back 1 step. And when the alien goes back 1 step, it's basically over here. So we want to make the alien go back another step. That way, it won't constantly trigger the case where it's always touching the border. So once we reverse course, we need to make the aliens advance 1 row. So when we get to this case, I'm going to do for int j is equal to 0. J is less than alien array dot size j plus plus. I'm going to do alien array dot get j dot y plus equal alien height, which is equal to the tile size, but it's more accurate to use the height. So if the height were 2 tile sizes, then we would jump 2 tile sizes instead of 1. But in this case, the alien height is just 1 tile size. So I'm just going to leave it as alien height. Maybe you want to add more aliens to your game, and maybe you want to add more images that are not necessarily 1 tile size. In that case, you would use the height of the image. All right, so now let's save and run the program. So you can see the aliens are moving to the right. And then when they touch the right border, they go down 1 row and they go towards the left. And then now they're touching the left border. They go down another row and they now go back towards the right. Okay? All right, so now we can create the aliens and they're moving back and forth and going down one row. The next thing we need to do is fire bullets at them. So up here, let's define some variables for the bullets. So just like with the aliens, we will have an array list to store all the bullets. So we're going to create an array list for the bullets, and then bullet width is going to be tile size divided by 8, and bullet height is going to be tile size divided by 2. And we need to give a velocity for the bullets so that the bullets can move. So when we fire the bullets, they go upwards. And to go upwards, we need to go in a negative direction. So specifically, it is going to be in a negative y direction. So int bullet velocity y is going to be negative 10. All right, so that's all we need for the bullet. We are not going to load any images for the bullets. Instead, we're just going to draw rectangles. So here, I'm going to create an array list. So bullet array is equal to new array list block. And then we need to add a click handler for the bullets. So here, I'm going to do else if e.getKeyCode is equal to key event dot vk underscore space. I'm going to create a bullet. So block bullet is equal to new block. And the x position is going to be ship.x plus ship width times 15 divided by 32. And the y position is just going to be ship.y. And then we need to pass in bullet width, bullet height, and the image, we're just going to pass in null. So the x position of the bullet is going to be ship.x plus ship width times 15 divided by 32. And the y position is just going to be the y position of the ship. So when we're finding the bullet, the y position is at row 14. So the bullet is just going to start on this row. And we need to place the bullet at the center of the image here. So that's why I took ship.x, which starts here, and I added an offset of ship width times 15 divided by 32. So this will place the bullet exactly at the center where this tank cannon thing is, okay? And if you want, you can actually do the math yourself and see how I came up with these numbers if you're still a bit confused, but I don't want to go into too much detail for this one specifically. So it could be a little challenge for you if you want to figure out how I came up with that exact number. So once we create the bullet, we need to store the bullet in the bullets array. So bullet array dot add bullet. And then now that we have all the bullets in our array, just like with the aliens, we need to do two things. We need to move the bullets with the velocity y, and we need to draw the bullets. So in this case, I'm going to draw a rectangle for the bullets. So I'm going to do g.setColor, color.white. So this is going to change the color of our pen to white. And now all I need to do is iterate through the bullet array. So for int I is equal to 0, I is less than bullet array dot size I plus plus block bullet is equal to bullet array dot get I, and we need to make a check. So when we fire bullets, the bullets are moving and the bullet only gets used up once we collide with an alien. So here I want to make a check if not bullet.used. So by default, bullet.used is going to be false. So only when the bullet collides with an alien do we switch this boolean to true. So not false, that gives us true. So if the bullet has not been used, then we're going to draw the bullet. So g.drawRect. And here we just need to pass in 4 values, bullet.x, bullet.y, bullet.width, and bullet.height. And now we need to update the bullet movements. So we just need to loop through the bullet array. So for int I is equal to 0, I is less than bullet array dot size I plus plus block bullet is equal to bullet array dot get I bullet dot y plus equal bullet velocity y. So we're adding a negative number, so this is going to go upwards. All right, now let's save and run the program. All right, now if I press the space bar, it's going to fire a bullet. There you go. And I can tap the space bar repeatedly. So currently we're just drawing a rectangle, and the rectangle is hollow. That means we are just outlining a rectangle. If you want a solid color for your bullets, you can just take this line and copy and paste it. And over here, instead of draw rect, we will do fill rect. Okay, so if I comment out this line, and if I save and run the program, you can see now if I press the space bar, it's firing white bullets. Okay, but just my personal preference, I prefer the hollow bullets, so I'm going to keep it as draw rect. Alright, so now that we have the bullets and the aliens, we need to check for collisions. So when I fire my bullets, I want to destroy the aliens. So for that, we need a collision detection function. So over here, I'm going to define a function, and it's going to be a boolean. And we're going to take in two blocks. So this is basically two entities, and one of them is going to be a bullet, and the other one is going to be an alien. So here I'm just going to use a collision detection formula, and it's basically a formula that detects an intersection between two rectangles. So I'm not going to explain how the formula works here. Maybe you can look it up. I think it'll take a bit of time to actually explain it, so just copy what I have here. So the formula is going to return a.x is less than b.x plus b.width, and a.x plus a.width is greater than b.x, and a.y is less than b.y plus b.height, and a.y plus a.height is greater than b.y. Okay, so this is the collision detection formula. And so I'm going to go back to the move function over here, and I'm going to make a check. So I'm going to loop through all the aliens. So for int j is equal to 0, j is less than alien array dot size, j++, block alien is equal to alien array dot get j. And then over here, I'm going to make a check. If the bullet has not been used, so not bullet.used, and if the alien is still alive, and we get detect collision between the bullet and alien, then I'm going to set the bullet.used to true, so we can no longer reuse this bullet, and alien.alive is going to be false. And then we are going to do alien count and decrement it, so minus minus. So this alien count is going to drop by 1 each time we destroy an alien, and then afterwards we'll do a check to see if the alien count is equal to 0. We're going to generate more aliens. So if I save and run the program, you can see if I fire a bullet, it collides with one of the aliens and destroys it. And if I fire 3, 2 remain and go upwards. And then here I've destroyed all the aliens. So now the alien count is 0, so what we need to do is generate more aliens. And before we generate more aliens, I want to also bring up another issue, and that is when we're firing bullets, we can fire as many as we want. As we continue playing the game, if I fire 10,000 bullets, those bullets that are now past the screen, they are still in the bullets array. And that is a problem because this is going to slow down our program because we will need to check through all of those dead bullets. So here I'm going to do some cleanup. So I'm going to make a check while bullet array dot size is greater than 0. So while we still have bullets in our array, I'm going to check and bullet array dot get 0 dot used or bullet array dot get 0 dot y is less than 0. So what does this mean? If the bullet array is not empty and the first bullet in the array has been used, or the first bullet in the array is above the screen, so if the y position of the bullet is less than 0, that means it's a negative number, it's gone past the screen, we want to clear this bullet. So I'm going to do bullet array dot remove at index 0. So this may not be the most efficient if you know data structures and algorithms. Instead of using an array list, you would actually want to use a linked list. But in this case, we're going to use an array list because I want to make this beginner friendly. So if you know data structures and algorithms, one enhancement you can make is just changing the array list to a linked list. Alright, so now that we cleared the bullets, I want to advance to the next level. So if alien count is equal to 0, I'm going to increase the number of columns and rows. But when I increase the number of columns and rows, I want to limit and have a maximum column and row set so that we don't create too many aliens. So I'm going to do alien columns is equal to math.min alien columns plus 1, or I'm going to do columns. So the number of columns in our game is 16. I'm going to do columns divided by 2, which is 16 divided by 2, which is 8. And I'm going to subtract 2. Okay, so the maximum number of columns we can have is 6. So we start at 3, and the max will be 6. And then alien rows, we're going to do math.min alien rows plus 1, or rows minus 6. So the maximum number of rows we can have would be 10. And then afterwards, I want to clear the aliens for the next round. So I'm going to do alien array dot clear. And we also want to clear the bullet array because if I destroy all the aliens for the current round and I fire 10 more bullets, the bullets will still be moving upwards, and we don't want those bullets to destroy the newly generated aliens. So I'm going to do bullets array dot clear. And then afterwards, I'm going to call create aliens. Okay, so now if I save and run the program and I fire the bullets at the aliens, you can see we generate more aliens. Okay, so let's destroy these aliens, and we are creating more aliens each time. Alright, so now we have the aliens, and we can fire bullets at the aliens, and we can create more aliens every time we clear a round. The next thing we need to do is add scoring and game over. So let's start with score. So over here, I'm going to do int score and set it to 0. And in our move function, every time we destroy an alien, I want to increment the score. So I'm going to do score plus equal 100. And whenever we clear the level, I want to give the player some bonus points. So I'm going to do score plus equal alien columns times alien rows times 100. So this is just some bonus points. And then in our draw function, let's draw the score. So here I'm going to do g.setColor to color.white. And actually, the color is already white because I've set it here earlier, but if you want to change the color of the score, you can do color.green or color.red, it's up to you. But in this case, I'm just going to leave this line here. And here I'm going to set the font as well. So g.setFont, new font, and I'm going to make it Arial, font.plain, and the font size, I'll make it 32. So when we're drawing the score, if we have a game over, I would add the word game over before the score, otherwise it'll just be the score. So let's add a boolean for the game over. So I'm going to go back up, and over here, I'm going to add a boolean called game over, and by default, this is going to be false. So back to the score, I'm going to do if game over, g.drawString game over plus string.value of score. And we need to specify an x and y position. So the x is going to be 10 pixels to the right, and the y position will be 35 pixels down. Else, if we don't have a game over, then we're just going to do g.drawString string.value of score 10 and 35. So when do we get game over? The aliens move down towards the ship, and if the aliens end up on the same row as the ship, we get game over. So here we have the aliens moving down by one row. So after the alien switches course and moves down by one row, I'm going to make a check. If alien.y is greater than or equal to ship.y, game over is going to be true. And when we get game over, we want the game to stop completely. In our action performed, I'm going to do if game over, game loop dot stop. So if we get game over, we're going to stop moving all the bullets and aliens, and we're going to stop drawing them again. So let's save and run the program. So we have the aliens, and if I fire a bullet at one of them, we get 100 points. So let's get some more points here. We have 600. Okay, now we get some bonus points. And you can see the alien is actually moving towards the left, so we have a bug somewhere. So you can leave it like this if you want. Basically, we should have reset the alien velocity x back to +1 for every new level, but up to you if you want to leave it like this. So here I'm just going to let the aliens come towards me. And you can see the aliens advance towards us and end up in the same row as us. So we get game over, and our score is 7,600. So I can no longer press the spacebar to shoot. I can't move the ship anymore. So all that's left for us to do is reset the game by tapping on any key so that we can play the game again. So as I mentioned before, for the new level, when we create the new set of aliens, we would do alien velocity x and set it to 1 again. So basically, we want to always make the aliens start moving towards the right because they are drawn on the left side. So if they move to the left first, then they would advance down more quickly. So this is up to you. You can keep this if you want, but I'll add this here. And to reset the game, I'm going to let the player press on any key. And resetting the game is actually very easy. So to reset the game, all you have to do is reset all the variables to the starting conditions. So over here, I'm just going to let the user reset the game by pressing on any key. I'm not going to check which key they pressed, so I'm just going to do if game over. And here I'm going to make this else if. So what we need to do is reset all the variables to the starting condition. So let's go through them one by one. So the ship can move left and right. So I want the ship back to where it was in the beginning. So ship.x is going to be shipx. And then we're going to clear all the aliens and the bullets. So alien array dot clear and bullet array dot clear. And then we're going to set the score back to 0. And we need to generate the aliens again. So I'm going to do alien velocity x and set it to 1. And the columns and rows, we're going to set them back to 3 and 2. So alien columns equals 3. Alien row is equal to 2. And then I'm going to set game over back to false. And then afterwards, let's create aliens. And then I'm going to restart the game loop again. So game loop dot start. So let's save and run the program. And you can see we have some aliens moving towards the right. And I'm going to fire at them. And I'm going to let this one go down 1 row. So now the velocity x is in the negative direction, so the alien is moving left, and if I destroy this one, the aliens start on the right side. So now they're moving towards the right, and now they're moving towards the left, and I'm going to destroy these aliens here. So let's keep playing. Okay, so I think that's enough for the score, and I'm just going to let the aliens slowly come towards me. Okay, so one more row. And then we get game over, okay? So at this point, I can press on any key and it will restart the game. So I'm just going to press on any key, maybe the enter key. And you can see we restart the game and the score is back to 0, okay? So now we have a fully functional game of Space Invaders. So that's it for this tutorial. We have a fully functional game of Space Invaders, and if you found this tutorial helpful, make sure you give this video a like. If you have any questions, let me know down below in the comments, and if you want to stay up to date for more tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.